Hi guys, I know that you had a lot of questions on Module 9.2 and some of you had some confusion on it. So I just wanted to take a minute and go over everything that we learned there and go over some of the questions on the independent practice and the guided practice. So the first thing I want to cover with you is that we learned two formulas in this unit or in this particular module. The first one is the area of a circle, and that could be calculated. The formula for the area of a circle is area of a circle, and I'm going to put that next to it so that you know it's not just the area of anything. So the area of a circle equals pi times the radius squared. And we did some work to show you how to get there, right? So we did this long, complex problem in order to take a picture of a circle and kind of like, cut it and kind of shape it together and everything in order to get that formula. So in the end, that's all you need to know is area equals pi times the radius squared. And then the second formula that we came up with was a relationship between the circumference, remember that, and the area. There was a relationship between these two things, the circumference and the area. And so that formula, after we did a lot of algebra, was the circumference squared equals 4 times pi times the area. And so those are the two formulas that we're going to be using for this particular module. And I know that we came up with the formulas for circumference in module 9.1, but we don't need that for this module right now, okay? We just are going to be talking about these two, okay? So the first question that someone asked me about was problem number 10 down here. So let's draw our attention. It says a circular pen has an area of 64 pi square yards. What is the circumference of the pen? And then give your answer in terms of pi. So I'm going to go back to our two formulas that we have. So the first formula that I have is area equals pi times the radius squared. And the second formula that I have is circumference squared equals 4 times pi times the area. And a lot of you were asking, how do I know which formula to use? And so I think this question is actually is where you might have gotten confused by that. And so if I look at the question again, it says a circular pen has an area of 64 square yards. What is the circumference of the pen? Well, they're asking me for the circumference of the pen. So I need to use this formula because it's the only one that includes both area and circumference. Does that make sense? So now that I know which formula to utilize in this situation, then I can just start plugging in what I do know. So a circular pen has an area of 64 pi square yards. So I'm going to include that in my formula, and so I'm going to say c squared equals, and I know this remains 4 pi, and that's being multiplied times the area, which is 64 pi. And that's a weird area to be given, and so that's what could be causing some of your confusion. But I'm just plugging it in. My area equals 64 pi, and so I'm going to use it the way that it is, okay? And so now I just got to simplify this side of the equation. So I'm left with c squared equals, now I'm multiplying. I'm using the distributive property right here, right? And so I'm just multiplying, actually. It's not even distributive property. Sorry about that. 4 times 64, which equals 256, and pi times pi is pi squared. And so this is where I'm left with the equation. And I don't want to find out circumference squared. I don't want to find c squared. I want to find out what c equals. So take a second to think about that. How can I find out what c equals by itself? Yeah, I can take the square root of it. So if I take the square root of this side, then I also have to take the square root of this side of the equation. And so I'm asking myself, when I'm taking the square root, don't forget, the square root of any number, in this case c squared, I'm asking myself what times what, and it has to be the same number, or variable in this case, gives me c squared. Yeah, c times c. So your square root is c. It's the base of it. It's what's being multiplied times itself. And so I'm going to do that to the same side. I'm going to say, okay, self, what's the square root of 256? And so I'm asking myself what two numbers that are the same what number times itself equals 256, and that number is 16. And then what number times itself gives us pi squared, and that is pi. Okay, so pi times pi equals pi squared, so the square root of pi squared is pi. And so our final answer is circumference equals 16 pi yards. Now that's confusing because some of you want to change this pi into 3.14, and you could totally do that. This module just wanted us to keep it as pi and be able to work it out that way. I don't know why they did it, but sometimes they just want you to keep it as pi. But you could transfer that into 3.14 and multiply 16 times 3.14 and figure out the actual estimate of how many yards that circumference would be. Hope that clarifies things a little bit for you, and let's move on to the next problem. So the problems that you guys wanted to discuss were 17. Let's start with that one, okay? And so it says the side of a square field are 12 meters. The sprinkler in the center of the field sprays a circular area with a diameter that corresponds to the side of a field. How much of the field is not reached by the sprinkler? And then round your answer to the nearest hundredth. So I have this this square shape, and that's not a real square, but you get what I'm trying to get at, right? And inside, I know that I have a sprinkler right in the middle, as much as it can be in the middle right there. And then it's spraying so that if you guys can picture that circle touching on all sides of it, because there, I'll just make it a little wider there. That's where the sprinkler is spraying. And the reason that I know this is because the diameter is the same as the side of the field. So if this is 12, my diameter is 12. And so they want to know essentially how much is not being covered by this. And so I've got to find out the area of the square, and I've got to find out the area of the circle, and then I've got to subtract the two, and the difference will be what's not being covered. Okay, so first of all, I know that the area of a circle equals pi times the radius squared. Let's tackle that one first. In this situation, I do not have a radius, I have a diameter, so I've got to be careful with that. I want a radius, and so if the diameter is 12, that means that the radius is 6. So area equals pi times 6 squared. And so I'm left with pi, area equals 36 pi. I like to change it that way. And that means since pi is 3.14, then area equals 113 and 4/100ths. So then I need to find the area of my square. And I know that that is just the side times the side, or the length times the width. You can think of it either way because it is a rectangle too. And so I know that that's length times width, and so I'm, or side squared, and I'm going to do area equals 12 times 12, and that equals 144. So now all I have to do is take these two numbers and subtract them. 144 minus 113.04, and I end up with about 30.96. Whoops, I'm sorry. I'm going to try and squeeze these numbers in without changing. No, I'm too close to the arrow to change the page, but you get the idea. It's 30.96 meters squared because we're talking area. So that's how you solve those types of problems. It's a multi-step problem, but in this case you had to find the area of both of them and then subtract. Hope that helps. So the next problem that you guys wanted to talk about was problem number 18, and so it is a silver dollar pancake served at a restaurant has a circumference of 2 pi inches, and a regular pancake has a circumference of 4 pi inches. Is the area of the regular pancake twice the area of the silver dollar pancake? And explain. So this is kind of like the area problems that we talked about a couple of weeks ago when we were looking at the area of a rectangle when we doubled it, when we doubled the size, and we said that the area was not doubled because that it was actually quadrupled times 4. And the reason that happened was because you had to double both sides of that rectangle. And if you only and so the area would actually be multiplied by 4. And so this is a similar question to this. So again, we have the formula that, since they're talking about the relationship between circumference and area, we're going to be using the formula c squared, circumference squared, equals 4 times pi times the area. That's how I know which formula to use, is because it's talking about both circumference and area. And so it says that the first pancake has a circumference of 2 pi inches. So I'm just going to replace that into the formula and say 2 pi, and of course that's going to be squared, equals 4 pi times the area. And so when I work through this, I want to find out what the area is in the end. And so I'm going to square this number, and of course I have to square both of them. So 2 squared is 4, and pi squared is pi squared, equals 4 pi times the area. And so now I want to get rid of the 4 pi on this side so that I am left with just the area. Whatever I do to one side, I have to do to the other. And of course, one of these pi's cancels out, and this becomes 1. So on this side, I'm left with pi, and on the other side, I'm left with the area. So the area equals pi for the first, for the pancake that's 2 pi inches in circumference. So the second pancake is 4 pi in circumference, and so I'm going to plug it into the formula again. And so 4 pi squared, according to the formula, equals 4 pi times the area. And so I know that 4 pi squared equals 16 pi squared. And continuing the rest of the formula, I've got to divide by 4 pi on both sides in order to get area by itself. And so I'm left with, as these two again, I get rid of 1 pi when I divide that, right? And so I'm left with 4 pi is the area. And so, just like the other problems that we've talked about before, the area of the first one was pi, and the area of the second one, even though it was double the circumference, it's actually quadruple in area. And that is, if you think about it, that makes a lot of sense based on when we did that picture at the beginning of this, oh, I didn't take a picture of it here, where we took the circle, and it was divided into 8 pieces, and then they kind of put those wedges together and did that, and remember it ended up being a quadrilateral in the end when they put all those pieces together. So that makes sense of why it would be 4 times in this situation. Okay? You guys also wanted to talk about number 21, and it says Mark wants to order a pizza. Which one is the better deal? And so in this case, I want to find out, like my 2 formulas again. I could either find the area. At the front door. Surprise, somebody's at my front door. So my 2 formulas that I was working with was area equals pi times the radius squared, and the second one was circumference squared equals 4 times pi times the area. And in this case, I want to know which one has the better deal for a pizza. So I want to find out how much pizza is on the inside. Like, how much pizza am I actually getting? And so, which formula do I want to use here? Yeah, I'm given the diameter in here, so I actually do not care about that formula here. I care about the area formula related to the radius. And so, of course, I've got to be careful because they're giving me it in terms of diameter, and diameter is not in my formula. It's a radius. So my diameter for Donnie's Pizza Place, if the diameter is 12, then the radius is going to be 6. Does that make sense? So I'm going to plug that into the formula and find out how much of an area is for the, I'm going to work on this one first, okay? So if area equals 3.14 times my 6 squared, then my area equals 3.14 times 36, which equals 113 and 400ths, or it's about, right? Okay. Now I need to find out how much it costs per square inch of the pie. So since I want to find out the cost per square inch, that's how I'm going to set up my math problem. Some of you might have divided it the wrong way, but I want to know the cost per square inch. So that's how I'm going to set up my problem. I need the $10 in my numerator, and of course that's my division line, and my 113 and 400ths of my inches squared is going to be down here. And so that's the problem that you're going to do. Got it? And so when you do that calculation, you end up with rounded about 9 cents for that cost of that pizza. So we're going to repeat the same process with the second size of the pizza with the 18 inches in diameter. Okay, so again, if we're looking at our pizza here with 18 inches, I'm writing right over it. That means that our radius is going to be 9 because it's going to be half of it. So that's what we're going to be plugging into our formula. So if I do my work down here, area equals pi times 9 squared, which equals area equals 81 times 3.14. I just used the commutative property of multiplication because that's how my brain was working right there. And I end up with area equals 254.34 inches squared. And again, I'm going to set up the cost per square inch. And so I'm going to be dividing 20, which is our cost, by the 254.34 inches that I have. And that equals a cost of, when I round it, 8 cents per inch. So the second one, the 18-inch diameter pizza, is a better value for your money. See how real-life math can be applied? You just saved yourself a penny per inch on your pizza. And the last problem that you guys wanted to talk about was problem 25 down here. And it says a bullseye on a target has a diameter of 3 inches. The whole target has a diameter of 15 inches. What part of the whole target is the bullseye? So this problem is asking us to take a look at a target. And so the target has a diameter of 15 inches. And then there's a bullseye in the center that has a target, or has a diameter of 3 inches. And so we're looking at the relationship between these two areas, okay? And so it's kind of a ratio between the two. And so we're going to be using that formula of area equals pi times the radius squared. And so they want to look at what part of the whole is the bullseye. So, so we want the part over the whole in regards to this. So if this diameter is 3, then my radius is 1.5. Do you agree with that? So if I'm looking at the bullseye, the part, then I have the area equals pi times 1.5 squared. Makes sense? And my whole is going to be using that same formula, the area, but of course I can't use 15, don't get caught into that trap. My diameter of the whole thing is 7.5 if my radius is 7.5 if the diameter was 15. So pi times 7.5 squared. Now looking at this division problem, this is really nice because I am seeing that I have pi divided by pi here, which is going to cancel out, right? And so I'm left with 1.5 squared, which is 2.25. And 7.5 squared is 56 and 25 hundredths. And so now I just need to simplify this, and I am left with 1/25, or if I calculate that, it's also 4 hundredths, and that equals 4%. So that's how you solve that problem. You're just looking at the relationship of the two with that part and the whole ratio. Okay? I hope that clarifies for things. I hope things started to click a little bit more. Again, there are two formulas for this, but you just have to look at what the problem gives you in order to determine if you're using that area equals pi r squared, or whether you're using that circumference equals 4 times pi times the area. Whatever the problem gives you, that's what you need to work through. Okay? I hope you have a great day, and be sure to watch my other math video for the lesson for today.